Imagine you're on a location road, on your way to a Dowel job site. Everything seems to be going quite well when your truck begins to lose momentum. Oh, the engine's running and the truck is in gear, but no power is getting through to the wheels. What just happened is a failure of one or more components in the rear drive axle. Single or tandem axles and their associated differential units generally give many thousands of miles of trouble-free service. However, there are circumstances that can substantially reduce their serviceable life. In the last 4 years, the cost of repairing axles and differentials has risen by 300 to 400%. The cost of downtime is figured in thousands of dollars. This is a typical single reduction axle. This type of axle consists of a banjo-type housing, a differential assembly, axle shafts, brake shoes, and drums. Inside the differential carrier is a set of spiral bevel gears and a differential unit containing spider gears and axle gears. These gears operate only for very short periods of time, so they require only splash lubrication. Power flows from the drive shaft through the differential unit to both axle shafts and wheels. The axle differential unit is the gearing assembly that allows the left and right wheels to turn at different speeds when maneuvering corners, curves, or uneven terrain, eliminating steering fight or tire scuffing. In straight-ahead driving, or equal traction or friction situations, the gears within the case are stationary, and the unit rotates as an assembly, the same speed as the axle shafts and both wheels. In this instance, let's assume the rate of axle rotation is 100 RPM. In negotiating a turn, the differential case continues to rotate at the same speed. The drive wheels must rotate at different speeds. The outside wheels has more distance to cover than the inside wheel in the same amount of time. The spider gears within the case rotate to compensate for wheel speed variations, allowing the inside wheels to slow down and the outside wheels to speed up. In this example, the inside drive wheel is now turning at 90 RPM, and the outside wheel is turning at 110 RPM. This difference in wheel speed prevents the wheels from fighting each other and the tires from skidding. Once the truck is back on straight road, the spider gears no longer rotate. The gears don't have time to overheat, so under normal driving conditions, splash lubrication supplies enough oil to resist excessive wear. Tandem axles are nothing more than two single reduction axles that have been brought together. Each axle has its own set of axle shafts and differential gears, but they are joined to each other by a power divider with its own interaxle differential unit. In normal driving, each wheel has 25% of the power, or 50% per axle. This illustration shows a typical tandem gearing. Power flow is from the drive shaft to the input shaft, then to the power divider. At this point, the power input is divided in two directions. 50% of the power goes through the helical gears to the forward axle. 50% goes through the power divider drive shaft to the rear axle. Working with the two axle differentials, the power divider differential eliminates skidding and wheel fight when turning. When turning with a tandem drive axle, all wheels rotate at different speeds. The axle differentials compensate for speed variations between each axle's own wheels. The power divider differential compensates for variance of speed between the axles. Wheels on tandem rigs also operate at different speeds on uneven road surfaces. The differential in the power divider compensates for this variation in wheel travel. This illustration shows a tandem with the forward axle wheels having to travel over a bump in the road, while the rear wheels are traveling over an even road surface. Since the distance over the bump is greater than the same amount of forward distance on level road, the front wheels are forced to move faster than the rear wheels. The power divider's differential compensates for this wheel travel variance. This entire gearing arrangement works well under normal driving conditions, but on rough and muddy roads, like many location roads, another gearing arrangement is needed. A lockout clutch in the power divider is used to provide maximum traction when road conditions are unfavorable. When engaged, this lockout clutch stops relative motion of the gears in the power divider and directly provides power to both axles. When the lockout clutch is engaged, there is no compensation between axles. Remember this, when you are on location in the mud, the switch is in. When you are off location, out of the mud, the switch is out. Under normal driving conditions, the lockout clutch is disengaged, permitting the power divider to operate normally and compensate for variable axle speeds. Under abnormal road conditions, such as snow, gravel, or mud, the lockout clutch is shifted by the driver to disconnect the power divider's differential action. Power flow is now direct to each axle. For better traction under adverse conditions, lock out the power divider. With the lockout engaged, if one axle loses traction, the other continues to drive. Remember, this is not the same as four-wheel drive. Even if the lockout gear is engaged, the differential in each axle is still working and provides different rotation to each wheel. At Dowel, it is our policy that the power divider lockout is never to be shifted while the truck is in motion. When you encounter abnormal road conditions and need to use the lockout, you should follow this procedure. First, stop your truck completely. Place the transmission in neutral. Switch the power divider in. Place the transmission in low gear. Slowly re-engage the clutch. When disengaging the lockout, the same method applies. Stop the truck completely. Put the transmission in neutral. Switch the power divider out. Place the transmission in low gear. Slowly re-engage the clutch and drive away. It is very important that these procedures be followed both when engaging and disengaging the lockout mechanism. If the truck is in motion when the power divider is in, stress will be put on gears and they will fail. Always remember to switch the power divider out before re-entering the highway. If you turn a corner with the power divider in, the wheels will still try to move at different speeds and you'll tear up the differential. The lockout mechanism and driveline of your truck are designed to last many thousands of miles, as long as they're correctly maintained and properly driven. But sometimes these parts do not seem to last very long at all. Instances of heavy loads, rough driving, and hard shifting take their toll on all parts of the driveline. At this point, stop the tape and ask your instructor any questions you have on how power dividers work. Weight has a great deal to do with how well your truck's drivetrain operates and how long it holds up. An axle has been designed to withstand specific maximum loads. Any load, though, works against the engine and drivetrain of a vehicle. Under the conditions that we in Dowel place our units, loading a truck with its maximum gross weight can result in bent and broken axle housings and broken and cracked gears. In other words, even a properly loaded truck can be damaged if not carefully driven when on poor terrain. In order to reduce this problem to a minimum, we must drive to match the conditions. Axles can be overstressed by resistant forces. Dowel trucks often encounter a lot of mud around service sites. As the truck makes its way to the wellhead, mud builds around the tires and front end. This mud can cause as much resistant force as having the truck loaded to capacity. Combine lots of mud with a full truck, and you have overstressed the axle, placing an incredible strain on all components in the driveline. This chart shows the results of dynamometer tests for axles rated at 55,000 pounds maximum capacity. At 55,000 pound load, you can expect 100% normal axle life. At 45,000 pound load, 10,000 pounds underloaded, the axle could live 300% or 3 times normal axle life. At 60,000 pound load, only 5,000 pounds overloaded, axle life expectancy could drop off to 60% of normal. If the axle is subjected to extreme overloading, say 75,000 pounds, axle life could dramatically be reduced to 18% of normal. The same kind of lifespan can be anticipated for axles of other weight ratings similarly overloaded. Trying to squeeze extra carrying capacity out of an axle is false economy, since it results in shorter life. All this is to say, if we know we are operating in a stressed condition, such as mud, that is our cue to handle with care. Drive your truck as if it were rolling over eggs, and you can't afford to break any. As of late, though, Dowel has been keeping the chickens really busy. Axles and differentials on Dowel trucks are only getting 1/10 of the usable lifespan that they should. This short service life is also due to other factors, such as bad road services, improper driving technique, and axle spin-out. All contribute to the failure of driveline components. When an axle is stripped down for servicing, your maintenance staff can examine damaged parts and determine the cause for failure. We would like to show you some damaged parts and explain to you why they failed. If the axle is relatively old and the gear teeth are lightly pitted along the contact line, it is a sign of normal wear. However, if the axle is relatively new and the teeth are similarly pitted, it is a sign of fatigue failure, a result of squeezing oil out from between gear teeth. To better illustrate this, the drawing on the left shows gear teeth properly meshing and a lubricating film of oil between the teeth. Though it is an exaggeration, it does demonstrate that oil rides between the gear teeth under normal driving conditions. The drawing on the right, though, shows how gear teeth are forced close together or even clash directly when rough terrain is encountered or when hard shifting occurs. Oil is squeezed out between gears and cannot cushion the metal-to-metal contact, causing excessive wear. Heavier loads can cause fatigue cracks to develop. Repeated opening and closing of the cracks under stress driving eventually makes the teeth so weak that they snap off. This type of failure can also be caused by slipping a foot off the clutch or by spinning and hitting dry ground. Repeated heavy loads cause cracks to open and close a little bit each trip. This kind of tooth breakage is distinguished by beach marks. Capacity loads combined with road shocks cause clean breaks, leaving a crystalline surface behind. Severe load stress causes bending of the drive shaft and axle assemblies. In turn, this throws the drive shaft pinion out of alignment relative to the ring gear, concentrating tooth contact areas at the tooth heels. The high pressures break down the oil film, damage the hardened surfaces of the tooth, and severe pitting results. All this is to say that even though your truck is properly loaded, driving on rough and muddy roads can create stress just as if your truck were overloaded. Careful driving is the only way to avoid damage. Stop the tape here and ask any questions you may have on weight and the power divider. Another instance of component failure can be attributed to improper driving technique. This is probably the single greatest cause of component failure. Driving technique must change to match each driving situation. Driving with the idea that you are on eggs will pay dividends in increased drivetrain life. and increase driver safety. Drivers should avoid hard shifting of either gears or the lockout mechanism, speeding over rough terrain, or allowing spin out under slippery conditions. Here are some examples of just what abusive driving can do to internal drive components. This is an example of a fatigue fracture of the drive pinion teeth, indicative of rough driving. Periodic heavy shocks on the gears crack tooth surfaces. After this occurs, more shock loads will break the teeth. If tooth surfaces are worn or pitted, concentrated areas of stress are being created at these surfaces. Here we have a specimen of side gear and pinion fracture, which may result from rough driving or may also be caused by overloading. Severe shock loads created stress beyond the design strength of the gears. Note the damage to the side gear was at the 4 points where the pinion meshes. The shock load was actually severe enough to split one pinion in half. These side gear spider teeth have undergone fatigue fracture. Rough driving on rough terrain will cause this kind of failure. Repeated shocks on the axle will result in fatigue fracture of gear teeth as shown. Continued rough driving finally results in total gear breakage and the complete destruction of the differential. Broken side spider gears are due to rough driving and are usually the result of continued shock loads. Normally, fatigue fractures first occur as cracks. Continued rough driving eventually causes a complete fracture. Side spider gear splines are worn out and broken right along with the side gears. Rough driving and repeated load shocks can have a devastating effect on the internal parts of axles and drive shafts. Now, what happens when adverse road conditions, icy spots, snow patches, mud, and loose gravel are encountered? Spin out. Under spin-out conditions, the differential gears in the axle come into play as if the truck were rounding a corner when the wheels rotate at different speeds. Relative motion of the differential internal parts begins, one wheel speeding up and the other slowing down. Remember, these gears are only splash oil fed and not pressure fed. They're designed for momentary, not continual use. With spin-out on tandem rigs, power always flows to the point of least resistance. With little or no traction at one wheel, the other three stop and the first wheel spins at twice the differential case speed. If the right front wheel is spinning, it is possible to fail the axle and spider gears. With this accelerated motion of axle and differential gears, centrifugal force fights the lubrication process of the oil bath and attempts to throw lube out of the differential case. Under sustained spin-out, the gears are starved of lubrication. Heat builds up as high as 1,800 degrees Fahrenheit. The lubricant then breaks down and internal parts are damaged. Trying to force your way out of the mud will only result in damage to the drivetrain. If you encounter spin-out, there is only one choice: wait to be pulled out. Let's look at some differential parts that have been damaged and failed because of sustained spin-out. In this photo, the parts became scored and galled. In some cases, the metal is plastically deformed, building up ridges on the spider arms. Here are differential parts that melted and became deformed. In fact, they are actually welded together. This part is twisted and heat deformed. Remember, damage to differential parts can occur in one spin-out alone. To prevent components from burning out or failing prematurely, it is essential to have an adequate lube supply in the differential carrier housing. Since the gears are the primary lube supply to the differential, lube starvation could occur. Oil, in addition to reducing friction, also acts as a cooling agent to prevent destructive heat buildup in driveline components. With a sustained spin-out condition, lube supply is decreased, heat builds, and finally, differential components fail, as this spider gear shows. With a single axle truck, there is essentially no choice. When spin-out occurs, you will have to get pulled out of your situation. Tandem axles, you remember, are equipped with a lockout mechanism. This device eliminates interaxle spin-out by disengaging the power divider's differential under spin-out conditions and providing maximum power to the axle that has traction. The lockout is operated by an air shift system and is manually controlled by the driver. When using the tandem axle lockout, moderate engine speeds and low transmission gears are important as they minimize the chances of differential spin-out failures. Remember, you're always going to do better by using your lockout before you get stuck than by waiting until you get stuck. 99 times out of 100, it's too late, and spin-outs can destroy a differential in less than a minute. As a rule, if you lose traction, wait to be pulled out. The principal cause of axle or differential failure is lube starvation, and the principal cause of lube starvation is improper operation of the tandem axle lockout mechanism. Remember, if your equipment can't work, neither can you.